Hi, it is a contactless tachometer which gives a speed in RPM using infrared technology, and we are using a Uniboard kit which uses a Atmega 128 microcontroller. As you can see that the RPM is displayed on the LCD. I will see. Now this is the circuit which will detect IR which is reflected from a rotating disc, which is reflected from a rotating disc. As you can see, this is the IR transmitter, then this is the IR receiver. When a white surface comes in front of the IR transmitter, that IR rays will be reflected and it is received by this IR receiver. And whenever a IR receiver receives the IR rays, the output of this transistor goes high, and this output is connected to the interrupt pin number 5 of Atmega 128 microcontroller. Since when a IR is detected, the output goes high, we are using the interrupt will be recognized on a high rising pulse, and in the main program we are counting the number of pulses which we are getting on the interrupt pin number 5. We are counting the pulses for every 200 millisecond, and we are taking 5 samples. So we are getting 5 readings in 1 second. These 5 readings we are taking for averaging. So these 5 readings will be averaged per second, and we will get a constant RPM value. Stop. Pause. Now we will see the working of the project. As you can see, the disc is rotating, and the white surface from the disc is reflecting the IR rays which are transmitted from the IR transmitter, and these rays are collected by the IR receiver. And this small voltage change occurring at the IR receiver, we are converting that to a TTL compatible voltages from this transistor, and the output of this transistor is given to the interrupt pin 5 of the Atmega 128 controller. And as you can see, as the motor is rotating, as the disc is rotating, we can see the RPM on the LCD screen. Now we will see our program. Here we have defined a long int, and we have defined a count_pulse variable and a count_RPM variable. Since they will be used outside the main also, that's why we have defined them as a volatile. Now here in the main we have defined port D as output port A as output port, and the port D. The port A is used for the LCD. Now these are the variables which are defined for taking the various values of the RPM count that will come. And now this is for initializing the interrupt port of Atmega 128. As you can see, we have set the interrupt to receive the interrupt on the rising edge, and now this is our program. You can see we are taking the values. This delay of 197 millisecond is the sampling time of the almost 200 millisecond. We have manipulated it since we are taking the 5 values, and these are the 5 values which we are using for averaging, and we are showing the value on the LCD screen. And this is our ISR. In the main ISR we are counting the pulses, and from the ISR we will go to the main, and we will convert the number of pulses into the RPM.